Hello, good afternoon. This is another exciting recorded lecture from Teresa Stack, Assistant Professor with Montana Tech of the University of Montana. And this lecture will cover most of the material found on the first exam for sampling and evaluation of health hazards. So some important formulas that you'll see on the exam. The only true in-unit conversion will be milliliters to liters. And of course, you should be able to go from hours to minutes to seconds and back and forth. There is one question which asks you to adjust a sample volume to normal temperature and pressure. So you need to know what normal temperature and pressure is, as well as you can see the importance of understanding the variables in this formula, which is pressure times volume divided by temperature equals the change in pressure volume divided by temperature, so that you can solve for any one of those variables. The important realization here is that temperature changes volumes if a volume is allowed to expand or not. If it isn't, if a volume is not allowed to expand, then a change in temperature must necessarily increase pressure. And so how this is related because of the ways that gases react in changes of pressure and temperature. Either the molecules move further apart or they become closer together. And because we're using this to measure air, this formula makes sense. And then the Q, which is flow, equals volume over time, liters per minute, or V is volume and T is time. Because you will be using the gas laws, you should convert Celsius to Kelvin, and that is to ensure you don't have any negative volume numbers, because Kelvin is minus 273 degrees or something close to that Celsius. Then we move down into the next set of equations, and Q average is just your average of pre and post. And you can come up with your Q pre and your Q post. It's the sum, the average of whatever type of calibration meter you're running, and usually it'll be, of course, dry cal or the Calibrator. Percent error is you've set your pre-cal, you've done your sampling, you've gone out in the field, you've come back, or your really post-cal as soon as you take the medium off of the workers before you bring your pumps back to the lab. Now you're doing your post-cal. And you want to make sure that these values are within 10% of each other because, and you should know the answer to the rest of that statement. So some of the ones that people have had trouble with before are, to remind you, I believe it's the welcome page, there is, or it could be the background page, it's definitely the first set of lectures that I gave. There's a Word document that says you should already know this. And it could explain some of these exposure calculations to you in different terms. So exposure is the concentration times the time, and that is when we're going to time weight the exposure. So remember, the concentration is the value, either the parts per million, or another way to see it is milligrams per meters cubed. So what's the weight of the material that I have on my surface area of my filter? And that material was gathered over a certain set of time. So concentration back from the lab times time it took you to run your pump and gather that concentration. And then, of course, you can weight that, and that's part of your time-weighted average, where you take the sum of your concentration times time, and you divide it by your sum of time. So you divide it by the amount of time that the worker was there, and that's your time-weighted average exposure. And yes, that is your actual exposure versus your 8-hour exposure. You can only use 8 in the denominator in place of the sum of time if you are sure that the worker was not exposed at all during the time period in which you weren't there. So some calculations that else you'll need to know are severity, and this will be talked about a little bit further down in this lecture, as well as using the standard analytical errors that you get back from the laboratory, and being able to put confidence intervals on your mean calculation of a worker's dose. So some other information, just background information, that in 1970 is when, of course, OSHA established the permissible exposure limits. It's really a little closer to 1971, but the OSHA Act was established in 1970, so folks used that as their benchmark. And at that time, OSHA adopted the threshold limit values from the American Conference of Governmental Industrial Hygienists. So they adopted the 1968 values. And there have been other permissible exposure limits that have been added, but most of the adopted PELs, which are not all of the PELs, there were only a certain set of PELs, which is 148, have not been updated since the time of their adoption. Industrial hygiene is the science of anticipating, recognizing, evaluating, and controlling workplace conditions that may cause workers injuries or illnesses, and definitely understanding how your sampling planning, protocol, and report writing evaluation fit into each one of those 4 basic steps that an industrial hygienist does. I think the one that's missing there is going back and re-auditing what you've done, but I suppose that is taken care of in some respects with your sampling plan. Industrial hygienists use environmental monitoring analytical methods to detect the extent of a worker's exposure, and then employ or recommend engineering controls, work practices, administrative controls, or other methods to control potential health hazards. So yes, you understand that this will be, or for some of you, is your role as the industrial hygienist or the safety and health professional. You may not understand the somewhat grave importance of a proper evaluation of a worker's exposure, using the right methods, being sure that you reduced error to as much as possible because of the recommendations that you'll ultimately be making to the employer about a worker's safety and health. So some components of an air sampling plan or strategy would be to determine your objectives, as well as what chemicals will be sampled, who, how many, and for how long, as well as what the more closely related, what I consider sampling plan is. Are you going to use one sample for an 8-hour period per worker, or are you going to break this up in intervals, as well as when is the best time to put samples on a worker where you can take a short-term or 15-minute exposure to look at any time they're over that short-term exposure limit. You also can do make an evaluation of whether a worker's ever over a ceiling by running a 15-minute short-term exposure limit. Shorter samples, but that means more samples, and it has to be, of course, part of your plan, and then more samples that you have to keep track of. So in selecting the appropriate media and equipment, the NIOSH analytical methods do help us do that. It is our cookbook, but we have to go back to being sure that we chose the proper chemical. And then just choosing the equipment, of course, it has to be calibrated, prepared appropriately, and handled in certain methods so that we don't contaminate our media before we get to the site and start to draw air and sample a worker's breathing zone. And then, of course, we have to wrap it all up and ship it to the lab, including the proper paperwork, chain of custody, so that it can be evaluated. When we get the evaluation back, then we get to interpret our data. And in the end, in interpreting our data, that's where we write a report, and then we can justify why solutions should be put into place, why we continue monitoring, why we choose to not continue monitoring, to upgrade or downgrade personal protective equipment, to maybe implement some training because of what you saw out there during your observational time. The report is the place to put it in very concise terms. Brevity and thoroughness is what I was told. So these are steps in a basic industrial hygiene process. So how do you determine why you're sampling? Is it for to look at health risks? Is it simply for compliance purposes because you have to, given previous exposures or visit by OSHA, or because you're using certain kinds of chemicals? Is there litigation involved? Do you think that somebody might sue you? There's been an accident. We need to see what the concentrations were in a certain work area. And that is also a role of some industrial hygienists who are contracted in. They look at recreating the events that occurred to look at what the inhalation hazards or skin hazards were in the area if workers died in that manner. It also helps us in choosing our appropriate personal protective equipment and ensuring that it's working like it should be, which is in, of course, evaluating our engineering controls, whether that be the ventilation or the noise dampening system that we put in place, or that work practices are being followed can keep exposures down. It helps us during spills, or also to just establish work zones. So maybe the loudest noise when you do your noise mapping is closer to a piece of operating equipment, such as a large fan or generator, and that is double hearing protection. But when you step back a certain number of feet or yards, you're in a different zone and you can remove the muffs, and then hopefully coming into the work area can have a completely different zone. So establishing those and documenting how they change out of time, as well as establishing zones, which is what I did in hazardous materials management when there's a spill. So your hot zone, your warm zone, your cool zone decon, and then your safe zone. We may be sampling to establish similar exposure groups so that we can group these people together and change our sampling plan over time. That would be part of a more long-range process, or if a new process has been put into place, maybe we need to establish our similar exposure groups to validate that the ones that we're using are correct. There's lots of reasons why you might be sampling. Or are you conducting epidemiological studies so that we're looking for the true burden of disease and exposure on our humans? And what's really neat about epidemiological studies and occupational exposures is that you have a fixed cohort, so they're easy to follow and track over time. So in determining why you are sampling, I hope you can see the connection of how this rolls into which type of report that you'll be writing, whether it will be a informational report or a persuasive report. And you can pre-plan your report if you have a really sound sampling plan. And you identify your objectives. This is part of identifying your objectives before you even start. So who to sample? Would it be our similar exposure groups, representative jobs in certain locations, so that we could start to maybe establish similar exposure groups? Subjects or workers, I guess subjects is a pretty rough word there, but workers that we suspect to have the highest exposure because of their position in the process, or maybe the temperature that they're working in, or the amount of time that they spend working in a certain zone where chemicals are being used, or noise, or maybe even ergonomic factors, right? And you certainly can't monitor all people at all times, so in some way that you can establish who you're going to sample and feel good that you're hitting the people with the highest exposure, and then maybe ultimately protecting the people with the lowest exposure. That's certainly prudent. Of course, training goes a long way too in personal hygiene and keeping work zones clean. We see a lot, or I have seen a lot, and I'll share a report with you of where cross-contamination of workers not completely deconning or going into a break room with simply rolling down their personal protective equipment instead of taking it off shows surface wipes that are high enough in concentrations that it could be damaging to a worker's health, especially with a dermal contact type of chemical. What to sample? So we definitely know what's there, our raw materials and our catalysts. Our byproducts are usually the hardest ones to sample because we're not quite sure what they are. We do have chemical and process engineers that help us with that. What chemicals are used in maintenance and cleaning, as well as, of course, what's the ultimate product of the operation in which we're in. Whenever possible, direct reading instruments get us as close to the truth, and we can always do a spectrum analysis when we're sampling for multiple contaminants and we're not quite sure what is there, and it'll help us find that. Where to sample, and this is also, I guess, how to sample and the different types of sampling strategies that you can use. So the most popular, I believe, is personal sampling, and that's when we're trying to represent in-drying air over the sample medium with the pump, what the worker's dose is, or what their exposure is. Their exposure, when it's gotten onto the sample media, is a surrogate for their true dose, but this is what we're using to evaluate or assess their risk in the workplace. Area sampling is where you draw a volume of air within an area such as a room. I guess it's not a good interpretation, but instead of being right next to the worker's jaw, you're trying to draw a volume of air into usually a bigger container like a bag or a cylinder, and to characterize what's going on in the entire room. It'll also evaluate the overall effectiveness of engineering controls such as fans, ventilation that's being used. And it's a way to identify where specific sources of agents or contaminants are coming from. Surface sampling, you could do this to determine secondary contamination. So when somebody comes in contact with the surface, you do a wipe sample. So you could be sampling to see whether any hexavalent chromium has been transferred from the worker's clothes into their eating area, into their cars, into their locker changing area. Also, surface sampling in a way, although this is kind of direct reading, can be used to evaluate whether there's lead in paint. That's a type of surface sampling, I believe. And then we're always using our observational methods. Those are personal as well. But to look at workers' behaviors, their work practices, because certainly how a worker works, whether they're in front of the process or behind it, where the fan is positioned in regard to where they're working, as well as other cross drafts. Are they next to the vat that's off-gassing, or are they close to the door in which the fumes would disperse before they got there? Your observational methods are really important in industrial hygiene. And are, of course, the core of ergonomics when we look at working postures, movements, forces, and workers' behavior, which can also be measured directly or indirectly. So how many samples to take? Boy, so debated. The NIOSH sampling strategy says the square root of n, where n is the number of workers in a similar exposure group, with a minimum of 7 to 9 samples so that we can get our representative sample, which means that if you have 5 workers, you still want to try to draw at least 7 samples. And it's easy to do in a sense if you have 4 samples per worker. 4 samples times 4 workers is 16 samples. It's easy to get up above the minimum number of samples. It's much harder if you only have 2 workers. And then in your samples, remember to always include your STELs. You try to sample for the period in which the worker's absolutely exposed, so we try to get as close to 8 hours as we possibly can. STELs cannot be less than 15 minutes, but they also, they can be greater than 15 minutes, but they should be as close to 15 minutes as possible, as well as overly sampling. And what I mean by sampling, overtly sampling. So can you sample for too long? It's preferable that you don't sample for longer than an 8-hour period. Although if your STEL goes over, that isn't quite as bad as your overall sampling plan going over. You try to get as close to that 8 hours as you can. And the number of blanks are defined by the standard, although there needs to be at least a minimum of 2 per 10, according to NIOSH, 1 per 20, according to OSHA. So why do we calibrate? It's to assure that our pump is behaving as it should be. We should also do some other pre-pump checks at that time, make sure batteries are charged before we go out there. We pre-calibrate to verify the accuracy. The pump is drawing at a certain rate in liters per minute. That's our cue. After we're done sampling, we verify that the pump is still drawing at that rate and that it is operated correctly throughout its entire time. We then would take the average of our pre and post and use that as our average flow and send that value to the lab so that they may calculate accurate concentrations. We do need to check though and ensure that pre and post do not differ by 10%. If they do, then we use the lowest value according to the OSHA technical manual. And this is important. This would be something that we'd have to definitely write down in our report as a limitation that happened during the implementation of our sampling plan or our sampling strategy. In following the protocol being we calibrate pre and post, we found an error, and therefore we sent the lowest Q to determine our concentrations. Pumps cause a change in atmospheric pressure. It's how air is drawn into the pump. So air comes into the sample inlet and then into the pump inlet. The pump does not push air when we are performing calculations. So now we have done our pre-calibration, we've sampled, we've done our post-calibration, we're getting ready to prepare our report. We have concentrations back from the lab. In running our data and finding out somebody's overall time-weighted average and your confidence in its ability to predict whether a worker is overexposed or not, we add on standard analytical errors to our concentrations or our values that we got, which is basically the severity of the exposure. And there's a method for doing that. The definition from OSHA is that our values, our concentrations, vary in some way from the actual true exposure due to sampling analytical errors. And we can account for these by making adjustments to the concentration values that we get back from the lab, and it's inherent that there will be some errors in our sampling methodology, our sampling execution, the analysis from the lab, as well as pump operation, which we know is within 0.02%. And in looking for our true evaluation of the severity of a worker's exposure, we make sure we put confidence intervals, both upper and lower, which is UCL, upper confidence limits, and lower confidence limits at the 95%, which is, 1.65 standard deviations from the mean if you think of this as a normal distribution, although more likely it's logarithmic. So how do we put our confidence intervals on an evaluation of a worker's exposure? And you should already be able to evaluate a time-weighted average, a time-weighted exposure average, as well as an action limit. So a worker's exposure versus a permissible exposure limit, as well as a worker's exposure versus what the action limit is, the worker's exposure in regards to an STL or ceiling. And now we take this one step further, and if you had 15 workers, we would come up with their mean time-weighted exposure average, and that would be our mean. And then we have our permissible exposure limit, and we basically take a ratio of their exposure by the permissible exposure limit. If their mean exposure is less than the permissible exposure limit, then we know that no violation exists and workers are truly underexposed. If this ratio is above, so our Y comes back to be greater than 1, then we need to put confidence intervals, well, actually anytime, no matter what our Y comes back, but more so if the Y comes back greater than 1, we need to put confidence intervals onto our severity. And we do this by adding the standard analytical errors. It'll be a value that we get back from the lab to our Y, or taking it and subtracting it, Y minus the standard analytical errors. So what I'm trying to show you is that right here is the correct equation, and that's a mistake on the slide. And this is where these equations come from. So what is a sampling strategy? It's an overall plan or framework for sampling that includes the number of samples, the methods, the accuracy of the objectives for implementing your sampling plan. And it helps us choose which resources we hope to use in the future, which ones we can save, and which ones maybe we need to put more money into. Our goals in our sampling strategy would be to protect health, compliance, establish similar exposure groups, protect against litigation, be cost efficient and effective, and ensure that the results that we're getting time after time when we go back into the field are accurate, valid, reliable, and precise. So this sampling method was part of, or is part of the NIOSH sampling strategy, and the PowerPoint presentation is much easier to follow, in my opinion, than the text that's here, but you do it in a step-by-step format. So first we ask ourselves, is there a chemical in the workplace? And if there isn't, then I guess we don't need to implement our sampling strategy until there is a change in the process. But if there is, then it's time for us to start to develop our sampling plan as to who may be exposed at concentrations that are above an action limit. And we know that an action limit is, most of the times, it's half of the permissible exposure limit. And the reason why it's important to us as occupational safety and health professionals and industrial hygienists is because it's where employers may have to start to take action to reduce those exposures or limit the dose that the worker is getting through programs such as monitoring, health monitoring, personal protective equipment. Hazardous communication should always be in the workplace. So when we're looking at the beginning of our sampling plan, our action limits are really important when we're trying to evaluate a worker's exposure or not. So for example, OSHA considers noise levels at or above 85 decibels over an 8-hour time-weighted average to exceed the action limit. When this happens, we need to inform workers that they have exceeded the action limit, and the employer will then implement a monitoring program. For benzene, it's 0.5 parts per million, or an STEL that exceeds 1 part per million. I'm sorry, that exceeds 15 parts per million. Here's your STEL. Oh, it's both. 8-hour 1 part per million, or short term of 5 parts per million. So this is your ST. If workers exceeded the action limit, then we need to identify which measures need to be put into place to bring people below the action limit and start to implement a more repetitive sampling program where we will continue to sample every 2 months until workers have been brought down below the action limit. I think that this is really important when you're looking at your exposures, is to not be focused, for those of you without experience, on the permissible exposure limits. It's the action limit which triggers some action from the employer in which your job will change and their responsibilities to the employees will change. So being below an action limit is really important, and being able to establish what the action limit is and being sure that we monitor it appropriately to determine a worker's exposure. Note if at any time a worker is above a permissible exposure limit, then we need to notify the employees, put control measures in place, and monitor at least monthly. My previous employer would go back every 2 weeks if we were above a PEL. We tried to always be below an action limit, but it wasn't always possible. So sometimes you're doing a whole bunch more sampling. So exposure assessment strategy, basic characterization happens when we anticipate what we're going to see out there, as well as we recognize the hazards that are in the workplace by understanding the process, doing research, and talking with supervisors. We then evaluate the exposure through developing, defining, and measuring our similar exposure groups, establishing profiles for different processes or work groups that we can later use to compare data against and put control measures in place, engineering, administrative, or personal protective equipment. We, of course, communicate and document things through written reports, oral, as well as, of course, the beloved PowerPoint presentation. We will implement our solutions and then, of course, reassess. Similar exposure groups. Similar exposure groups are workers that have the same exposure profile because of the similarity of the tasks, the frequency of the tasks that they perform, as well as the materials that they use or processes of which they work. And it's not as easy as it seems to establish similar exposure groups. Sometimes you can have 3 workers in a shop that are doing mostly the same thing, but they actually all have very different tasks in which they perform, and their locations in the shop or the work area are separated enough that their exposures are different, and you can't put them into a similar exposure group, which means you have to sample each one individually. All right, so what kind of sampling methods? Since it's a review, it doesn't flow, but now we're looking at different kinds of sampling methods. So the first one is we sample for the full period, which would be an 8-hour duration or as close to that 8 hours as we can get, but we just use one sample. And that's a continuous single sample. Maybe we can integrate those with full period consecutive samples, but a full period, one sample doesn't really tell us much about the fluctuations. It's like turning the noise meter on in the morning and then turning it off in the afternoon and simply looking at what the peak was. That probably tells us a little bit more than, that would be the same thing as a worker's time-weighted average based on one sample. Or not looking at what the peak was with the noise meter, we would look at what the average exposure is. It doesn't tell us anything about peaks and valleys. We do this through our full period consecutive samples, which is more than one. And we try to have them consecutive so that we don't just sample for half a period. And they don't always have to be broken up in the same amount of length. It could be maybe longer ones in the morning while they're getting started up, shorter in the afternoon when the process is really running, and then lengthen out in the afternoon when they're doing their cleanup, unless it's the cleanup that you feel as though through your observational techniques is causing the exposure. Grab samples are somewhat piecemeal, and that's when we go in and we just take a sample in a random period of time for a short duration. Don't really have much overlap, but it can help us establish where maybe those peaks are occurring within a process and save money before we take 60 samples in a work area. We just take some grab samples to see where those levels truly are, or might be. They are in the room, but they might not be to the worker. And this is the NIOSH chart on the same thing. So also as a reminder, the material that's posted under background is a good review, and I believe it's called What You Should Already Know Coming Into This Class. And that material is also part of what's on the exam. I appreciate your attention. I hope you have a good day and find this useful, even though I had some errors.